This video is on fission. Question number 1. Define nuclear fission. Nuclear fission is when a heavy nucleus splits into smaller nuclei. Energy is released in a nuclear fission process. The fission fragments will be more stable than the original nucleus. So taking a look at this average binding energy per nucleon versus number of nucleons in the nucleus graph, any heavy particle to the right of this vertical line results in fission. It wants to get closer towards iron because iron is the most stable element. And every element to the left of this vertical line, it wants to go through fusion because it wants to become more stable. The goal is to get as close to Fe iron as possible. Question 2. Give 2 examples of nuclear fission. So from this website, I put a box here. You have uranium-235. You throw a neutron at it, it becomes uranium-236. And 85% of the time, you're going to get barium plus Kr, which I believe is kryptonium, plus 3 neutron particles. And 15% of the time you're going to get 236 uranium plus the gamma ray. So here's another example. You have plutonium 239, you throw a neutron at it, that neutron goes into the nucleus, so now you got plutonium 240, it becomes unstable, and then it becomes xenon plus Zr plus 3 neutrons. It says here about 73% of all absorption reactions result in fission. So we got fission here on the top, and we do not have fission here on the bottom. You could call it gamma decay. Same thing up here. We have fission on the top, we have gamma decay on the bottom. Define chain reaction. So here's chain reaction. A nuclear chain reaction occurs when one single nuclear reaction causes an average of 1 or more subsequent nuclear reactions, thus leading to the possibility of a self-propagating series of these reactions. The 1 or more is a key parameter of reactor physics. The amount of reactions must be changed using the control rods to raise or lower the power so that the number of neutrons present, hence the power generation rate, is either reduced or increased. So take a look at this image. We have a uranium-235 nucleus. We throw a neutron at it. It gets absorbed into the nucleus. And then the nucleus splits. You can see it says nucleus splitting. Then we have fission products plus 3 neutrons. And these 3 neutrons hit 3 uranium-235 nuclei. Then it repeats. Define critical mass. Units. Critical mass is the minimum mass necessary to sustain a controlled continuous fission reaction. Question 5. Define induced process. During an induced process, nuclear fission reactions are caused by the bombardment of neutrons because they are rarely spontaneous. Fission of a nucleus rarely happens by itself. Question 6. What are the uses of the following objects in a nuclear reactor? A control rod absorbs free neutrons. So when we insert the control rod, it decreases the amount of free neutrons, which causes less nuclear reactions. When taken out, we're going to get more nuclear reactions. What's the moderator? It slows down high energy neutrons to low energy neutrons, and we need this for the neutrons to be absorbed by the nucleus. Heat exchanger. Takes heat away from the moderator, things get hot. Fuel rod, it contains the fission products like uranium. Question 7. State 2 benefits and 2 drawbacks to using nuclear power. Benefits: high energy density and high specific energy, no air pollution. If you forgot energy density and specific energy, take a look at a previous worksheet. Drawbacks: high initial startup costs, possibility of nuclear meltdown. Not good. Okay. So this website says in 2011, nuclear power provided 10% of the world's electricity. We got 439 nuclear power reactors operating globally, operating in 31 countries. Okay. Question 8. Below is one example of a fission reaction. Determine the change in binding energy to 3 decimal places. The change in binding energy, you see, I have something minus something. That first parentheses is what we get at the end here. Okay? It's the total binding energy of barium plus molybdenum plus a neutron. That's these 3 here. And it's given to us here. Minus the total binding energy of californium, which is here. So we got products on the left, reactants on the right. I think. Okay. Question 9. A typical fission of 1 californium-252 nucleus releases about 184.07 MeV of energy. Determine the amount of energy in joules which is released from 10 kilograms of pure californium-252. So 10 kilogram is 10 to the 4 grams. We convert it to number of atoms. And then we convert it to joules. So 7.0379 times 10 to the 14 joules. That's a lot of energy.